Hello everyone. Today we are going to discuss the derivations for the discharge, work done and power required to drive a single acting reciprocating pump. So let's consider a single acting reciprocating pump as shown in this figure. Let's assume D is the diameter of the cylinder, A is the cross-sectional area of this cylinder or piston, this R is the radius of the crank. So this is R, the radius of the crank. This L is the length of the stroke, which is equal to 2 times of the radius of the crank. So this is L, which is equal to 2R. And this is HS, which is the height of the axis of the cylinder from the water surface in the sump. And this is HD, which is the height of the delivery outlet from the cylinder axis. Volume of the water delivered per revolution or discharge of the water in one revolution is equal to area of the cylinder multiplied by length of the stroke, which is equal to A into L. And we know that number of revolutions in 1 second is equal to N by 60. So the discharge of the pump per second Q is equal to discharge in one revolution multiplied by number of revolutions per second. Discharge in one revolution is AL and number of revolutions per second are N by 60. So the discharge of the pump per second Q is equal to A into L into N by 60, which is equal to ALN by 60. Weight of the water delivered per second W is equal to mass of the water delivered per second into acceleration due to gravity. And we know that mass of the water delivered per second is equal to discharge per second multiplied by density of the water. So mass of the water delivered per second is Q multiplied by rho, where Q is the discharge per second and rho is the density of water. So in this case, weight of the water delivered per second is equal to rho into G into Q. So it is equal to rho G ALN by 60. Work done by the single acting reciprocating pump per second is equal to weight of the water lifted per second multiplied by total height through which the water is lifted. We know that the total height through which water is lifted is HS plus HD. So work done by the single acting reciprocating pump per second is equal to W multiplied by HS plus HD. And we know that the value of this W is rho G ALN by 60. So the work done by the single acting reciprocating pump per second is equal to rho G ALN by 60 multiplied by HS plus HD. So the power required to drive the single acting reciprocating pump is equal to work done by the single acting reciprocating pump per second, which is equal to rho G ALN multiplied by HS plus HD divided by 60 watts, which is equal to rho G ALN multiplied by HS plus HD divided by 60 into 1000 kilowatt. So this is all for today. Thanks for watching this video.